Ladies and gentlemen, I'm John Duke. I'm a NOFA board member, so welcome to Resources to assist in reaching your soil health goals with Maggie Payne, Jack Loomis, and Joel Betts. These are all representatives from NRCS and different conservation districts. So I'm going to let them introduce themselves as they take the floor, but we've got a couple of housekeeping things here for NOFA Mass. Also with us today is Jocelyn Langer, who is the executive director of NOFA Mass. Welcome. The first slide we have here is our native land acknowledgement, which you all know we are presenting, attending, and hosting this workshop from land that was inhabited and managed prior to the European colonization. If you have been attending other NOFA Mass workshops, you've seen the slide before. It is offered to remind us that the land we steward has a political history and a justice context. Descendants of white colonists and white immigrants own most of the land in this country due to racist practice, beginning with broken treaties and extended through sharecropping and redlining and mortgage lending discrimination practices that are ongoing today. Please take a moment to consider the role that land ownership plays in the economy, in economic security, well-being, capacity, and self-reliance, and political power of all people. And consider this in the context of who owns the land today and why. This interactive map can be found at nativelands.ca. It's a great interactive map. You can click on it and see who previously occupied the lands that you are working on. I just want to take a moment to recognize all of our sponsors for the conference. Without them, this would have been a whole lot more difficult to pull off. So please take the time to support them when you can. They all can be found in our virtual vendor area. And that is about it. So thank you all for being here. Thank you, speakers, for coming. And with that, I'm going to turn things over to Maggie. Welcome, Maggie. Take it away.
All right. Thank you. Anyway, thanks everybody for coming this morning. My name is Maggie Payne. I am a resource soil scientist with the USDA Natural Resources Conservation Service. I'm based down in Wareham, Massachusetts. And I've been, so my background, I've been working with USDA Nrcs for about 14 years. My background is mainly in soil science. So I did the mapping of soils, and then moved into doing more what we call resource soil science work, where we work with a lot of farmers and landowners in doing conservation practices on their property. And so I do soil assessments and wetland assessments. And a part of what I do is soil health assessments and soil health management. So that's what I'm here to talk about today. I'm here also with Jack Loomis and Joel Betts. And so they're based out of both Westford and Holden, out of some of our other field offices, working with NRCS and the Worcester County Conservation District. And I'll let them give a little intro when they start speaking. I'm going to start off, and then they're going to take over here. So what I would like to do is we're going to share today some of the resources that we have to, I guess basically the government and other resources to help people in reaching their soil health goals. Let's see, make my slides go forward. So next challenge, there we go. So I would like to mention, we want people to ask questions. We want this to be as interactive as we can. I'm going to go through my presentation, and then we'll have some time for questions there. Feel free, as questions come up, write them in the chat. We'll make sure that we get to them. Or when I'm done, we'll unmute yourself and ask those questions. So I'm going to give a little bit of overview of just what soil health is, how we define soil health. And because my background is in soil science and soil mapping, what these differences are between what we call inherent and dynamic soil properties. And then a little bit about assessing our soil health and managing for soil health, how we look at that through through NRCS and USDA eyes. And then I'm going to hand it over to Joel and Jack, who are going to speak a little bit about our NRCS planning process. So how you really can work with NRCS if you're interested in doing that. It can be kind of a complicated process, but hopefully we can simplify that for you. And what we do for soil health management planning, this is sort of up and coming with us, and then some of other funding resources that we have. So I'll let them cover those items today. So defining soil health. Soil health has been, so our agency, the U.S. Department of Agriculture, and NRCS, the Natural Resources Conservation Service, we were founded, the Conservation Service originally was this Soil Conservation Service, or the Soil Erosion Service, was founded after the Dust Bowl, because of the Dust Bowl. And mainly our goal was to preserve soil, keep soil on the land and being productive. Initially, a lot of our focus was on just sort of keeping that soil in place. We realized that we were not managing our soils correctly. We were losing a lot of our soils physically. It was just eroding off of the land. And so our agency was founded in order to try to preserve that. And so a lot of our initial looking at soils was really based on just sort of the physical, we're losing our soils through erosion, and what can we do to help that? And so we did a lot, we've done and still do a lot of practices like putting in buffer strips and things that'll just sort of keep the soil from going into the rivers or going off of your field. And those were helpful. But as soil science has evolved, we've discovered, and I think anybody involved with NOFA has definitely heard a lot about soil health and soil management, and how important soil biology is, and how that influences the health of the soils and how well the soil functions. And so we've sort of evolved into looking more at what can we do to our soils, with our soils right on the land, and how we can improve the soil health and the soil biology in order to maintain our soils. And so over the course of the years, we as an agency have kind of evolved to look more at soil health and some of these practices, and it continues to evolve. So currently, the definition of soil health is the continued capacity of a soil to function as a vital living ecosystem that sustains plants, animals, and humans. So in that definition, a few of the things that are highlighted is that it's the continued capacity of the soil. So it's a system that functions on its own. We don't need to be providing a lot of inputs to it. We don't need to be managing it really intensively by adding a lot of things to it, but it should be able to function on its own. And then the living ecosystem part of it is highlighting the importance of this is a living ecosystem. We're focused on the biology is really the basis of what soil health is. And then finally that function. So soils do function for us. I don't know why I'm having trouble with this. Okay, here we go. So what are the functions of soil? We need them for all of these different things. What they capture, filter, drain, and store water. That interaction between soil and water is hugely important, and that's where we see, if it's not functioning right, we get erosion that happens, or we don't have a lot of water storage in our soils. It might not be draining through. That interaction between soil and water is really one of the most important things, important functions of our soils. But also soils store and cycle carbon. So that carbon cycle that happens within the soils, it's been shown that since the start of intensive agriculture in the country, we've lost over half of the carbon that's stored in our agricultural soils. And so trying to bring that back up is one of the important aspects of soil health management. Soils are just a physical stability and support. So they're just, they're there they hold us up, they support our structures, they support our plants, they support everything that we have on the land. They also buffer and detoxify pollutants. So this is why we put septic systems, we put infiltration systems in the soils, because they're actually detoxifying what we're putting in there. They'll protect plants from pathogens and stress. So the soil is important for protecting those plants, and cycling nutrients is another really big important one. The key with all these functions of the soil is 90% of those functions are mediated by soil microbes. So that's where that living ecosystem comes in. It's not just a mineral material down there. It's the living part of it that really is what influences those functions. What I'd like to get back to before we get into the soil health part is that soils are more than just that very surface, what we often think of in agriculture. We're thinking of like the top 6 to 10 inches of soil. But really in soils are, when we map soils, when we look at soils, we're looking at the top 2 meters or 6 feet of soil. And that's really the functioning part of soils. And so it's important to think of that whole soil profile. When we talk on soil science, we're talking those physical characteristics of a soil, including things like the soil texture, how much sand, silt, and clay is there, what the structure is it how good that structure is, and then also what the color. We look at the soil colors, and we'll define a soil based on what these different profiles are. The A horizon is usually considered the topsoil. That's a lot of the focus is put on that in agriculture in that A horizon. But there's also important things and important functions that are happening in the B horizon. Right down below that is still an active zone of soil formation and soil biology is happening down there. And then the C horizon is really mostly just the parent material. So whatever material your soils were formed in around here, there's a lot of glacial materials. So that definitely influences your mineralogy and your texture, your drainage, and things like that. So it's important to know what your whole soil profiles look like, what kind of soils you're dealing with below that, even below that very surface of the soil. And you can see, I really like this picture. Hopefully it's showing up well for you. You can see how the roots of these plants are going all the way down. That's 44 inches. So we're almost 4 feet down into the soil, and look at how many roots there are down there. From just, this is in a hay field. Those roots really penetrate pretty far down into the soils, and so it's important what's going on down there, and it's important to know what's happening deeper in your soils. And so this sort of gets into these two different categories of the properties of soil, how we define them. We talk about both inherent soil properties and dynamic soil properties. So inherent soil properties are kind of what we're looking at. If you pull up a soils map, so we have the soil types are mapped throughout the country through Soil Survey has done this over the last, I think it's been 100 years or more that they've been mapping soils. And we really have almost a complete map of all the different soil types throughout the country. This is what we call the inherent soil properties. So these are the properties like what the parent material is, what the texture is, what the drainage class is, things like that. These are properties that have formed over the course of sort of a geologic time frame, over a long period of time. It takes a long time for a soil to form, and they're mapped at a larger scale. So it's not a super detailed map. You're not going to find a difference between one like vegetable bed and the next in your inherent soil properties necessarily. But it's an important thing to know what kind of soil you're dealing with, what those textures are, what those parent materials are. And then getting down onto a smaller scale and soil properties that we refer to as dynamic soil properties. These are things that people really can influence. These are things that can change over the course of a human time frame or even over the course of a few years. So things like the percent carbon, how much carbon is in the soils, what the structure is of your soils, and then the things like the porosity or what the aggregation is like. And these are really what we're talking about when we're talking about soil health and management practices that we're doing on our soils. Can influence these things a lot. And so it's important to know both of these properties. What are your inherent soil properties? What are you dealing with? And then what are the things that you really have control over? And what are the things that you can influence?
Maggie, I'm going to jump right in. Quick question about
go ahead.
material. Somebody just asked, could you just explain what parent material means before you go too much deeper?
Yeah, parent material is the material from which the soil forms. So it's the geologic material from which it forms. So around here is a lot of glacial material. So whatever was left over from the glacier, left behind from the glacier, and then over the course of thousands of years, the soil has weathered and formed out of that material. So we refer to that as the parent material. And that can really influence what the texture is mainly, and how well drained the soil is. So things like, we have a lot of glacial outwash down here that is really sandy and gravelly. Glacial tills are what was underneath the glacier and can be very compacted, and that can make a compact layer that water won't infiltrate through very well. And so things like that can be a big influence on your soils. And you can find information on that. So we have the Web Soil Survey is where you can find soil maps for any of your areas. So this is a resource put out by USDA, Nrcs, the soil survey, that you can zoom into your area, find what soil type you are in. So that's what all these little polygons are, these orange lines with numbers, and it'll give you information such as, it gives you sort of the name of the soil, what we've named the soil, give you information on what the drainage class is, where the water table would be, what your typical textures are at different depths. And again, this is sort of at a broader scale, so it's not going to be really site specific, but it'll give you a really good idea of what to expect on certain properties, and what your expectations can be. If you have this is a super brief overview of Web Soil Survey, but if you have questions on and want to use this and need assistance, feel free to reach out to me or anybody in NRCS. Excuse me, we're all knowledgeable about using this resource, and we're here to help people access it. So definitely it's there, and it's a really useful resource. And so the soil survey can give you information on your inherent soil properties, sort of what you're dealing with on your property, what your capabilities are. But then on that same soil, you have the influence over those dynamic soil properties. So this is an example of the same type of soil. So it's mapped as this. These are two different fields side by side, mapped as the same type of soil on that soil survey, but the management has been different over the course of this, in this example, over 17 years of intensive tillage on the right-hand side. On the left-hand side, this is the same type of soil in forest. And you can see how different that soil surface is looking. The main difference is the amount of soil organic matter, 4.3% on the left-hand side, 1.6% on the right-hand side. Just through all of that tillage, it's really lost all the organic matter, lost all of that structure, lost a lot of the soil biology and the function of that soil. And so that's the difference between your inherent properties. So you have probably the same soil textures here, but your dynamic properties have definitely changed, that organic matter and structure and things like that. And that's what we're talking about when we're talking about soil health and soil degradation. So this is just a little diagram of what's happening in your soils if you're not managing it correctly. So if you have an increase in tillage, this is basically what's happened in a lot of our intensively managed agricultural soils throughout the country. We've just had a lot of tillage where we're breaking up all of the structure in the soil, losing a lot of the residue. So all of the inputs from organic matter, anything that you're growing material out of the soil, but then you're just harvesting it, taking it right off. So you're not putting back in any organic matter. All of that material is leaving the site, and you're losing the amount of diversity. So you might be having just a monocrop. You're losing diversity of plants, and through that you're losing the diversity of animals and microbes as well. And what that leads to is a decrease in soil organic matter. That's what SOM stands for. So because you're not having any more organic matter inputs, you're losing organic matter. This can result in increase in erosion, increase in compaction, because of that loss of organic matter. And also what happens is when you have less organic matter, you have fewer aggregates. So aggregates are when your soil sort of clumps together into little aggregates. I don't know what the other word for that would be. Little clumps, and that won't break apart in water. But if you're constantly tilling that material, those will break apart and just turn into sort of individual sand and silt grains. And that can result in surface crusting and surface compaction. So that's when you can see on this image that crust and then sort of the cracked material at the surface, which again results in a decrease in infiltration. So that really important part of that water soil interaction is right at the soil surface. What's happening right there when that raindrop hits the surface of the soil? Where is it going? Is it going to go infiltrate, or is it going to run off? If it doesn't have any kind of pore space at the surface, any kind of access into the surface of the soil, it's going to start running off. Even on any kind of slope, you'll start getting surface erosion. That results in more decrease in the organic matter, loss of your nutrients, loss of your topsoil, eroding right off. You'll see this resulting in more ponding, less storage of water in your soils, lower nutrient availability, higher disease. Now we're just getting, it's getting worse and worse. Crop yields, hunger, malnutrition. Anyway, that's the downward spiral of soil degradation. This is what it looks like. You get crusting, you're getting lower infiltration, more inputs of you're gonna have to put in more inputs of pesticides, herbicides, fertilizers, things like that, and definitely erosion can be a result of that. But we do have, on the other side, we're having, if we can manage these soils correctly, we can improve this. We can bring these soils back to life. And the key to that is improving that biological activity. Sort of the key to all of this soil health management is looking at the biology. Like I said, 90% of all of the soil functions are influenced by those soil microbes and what they're doing for us. They're cycling the nutrients, they're turning over the organic matter, they're doing all of these functions for us. And so making sure we're focusing on providing a nice habitat for those microbes will start to bring back the health of the soil. And so starting there, we'll get more organic matter turnover, bringing that organic matter back into the soil, improving our nutrient cycling. You might not visibly see this in your soils until you're really improving the structure of the soil, improving your available water, and things like that will happen eventually. And like I said, this is a really nice, so this is an image of just the surface of the soil. This is where a lot of the action happens. It's when that water drop hits the surface of the soil, is it hitting something that looks like this, where it can infiltrate right in and not run off and not cause erosion? Or is it going to hit something that is sealed off and is going to cause that erosion? The key to soil function is that soil biology, and this shows a lot of there's within that soil surface is all of these different zones of influence. I'm not going to get into these technical words here, but just know that there's a lot of different areas in the soil that are providing that habitat for the microbes, providing structure and making that soil more highly functioning. And so that's at the very surface. Again, I want to remind you that it's also happening deeper down in. So don't just focus on the very surface of your soil, but we're also looking a little bit deeper too. This is just a fun video. I'll let it run through of comparing two different two different soils that have, so the one on the left has those microbes in it. It has some soil life in it, but it doesn't have the complete array of all the different types of soil fauna. So it doesn't have the sort of macrofauna, or what we call those ecosystem engineers, like the earthworms and the insects that really break down and incorporate the organic matter. Where the soil on the right, you can see how quickly over 15 weeks, those earthworms and those macrofauna are incorporating all that organic matter into the soil. And having that fully functioning suite of soil fauna is really important in having a fully functioning soil and being able to incorporate all of that material into your soils. And so you can see, even with microbes in there, you're not getting that full mixing of all of that organic matter into your soil. And so that is a quick overview of sort of soil health, what we're talking about with soil health. I'm going to move into now just sort of how we talk about soil health with NRCS. So NRCS, we're the Natural Resources Conservation Service. We're a government agency. We have to work within our bounds of how we do this, and we have a lot of terms that kind of are unique to, or maybe not unique, but are like our government terms and things that we need to work with. But so I just wanted to sort of transition into talking a little bit about that and how we talk about soil health and what we can do to assist people in getting healthier soils, basically. So one of the things the way that NRCS works is we look at what we call resource concerns. Basically, this is a resource concern as far as soil health goes, is just you've lost that functioning soil. We don't have healthy soils. It's lost some sort of function. We look at this through, we have these 4 different categories of resource concerns as far as soil health goes that are indications that we've lost that soil functioning capacity. So things like compaction, the loss of organic matter, so organic matter depletion, soil organism habitat loss is another resource concern, and then aggregate instability. So those are just sort of our terms that define where we're seeing some kind of loss of soil function. And we look at that by assessing. We have this sort of infield soil health assessment that we'll look at, and looking at some of these different indicators. So we can do this. So looking at indicators like how much residue is there? Is it breaking down? Is there soil crusting at the surface? Is there ponding happening? What does the soil color look like? Is it really dark, or is there a lot of organic matter in it? Or is it really light colored where it looks like you've lost a lot of organic matter? So just really, it's pretty easy things to just look at your soil, feel your soil, and make some assessments on this. This is an assessment that we do as NRCS employees, but I'm going to run through some of these indicators because there's a lot of things that you can look at in your own soils and kind of make some assessments on your own too. So I'm referring to these all as these resource concerns. And that's just sort of the term that we use as NRCS, but again, that resource concern is like where we're seeing some issue or some loss of function. And so one of those resource concerns, like I said, is compaction. So you don't want to get an indicator that you've lost some kind of function of your soil as far as soil health goes, is that you have some kind of compaction. This can happen either right at the soil surface, or it can happen a little bit below, or we call that like a plow pan. Usually it's like 7 to 10 inches down below the soil surface, where you've compacted the soil enough where you've lost a lot of the pore space. In a healthy soil, in this little graph, you can see an undisturbed soil. Over half of the volume of a healthy and undisturbed soil is air and water space. Is really that pore space. That's where all the action is happening. Less than half of it, or about half of the volume of the soil, is really that mineral material, and the organic materials is in a good soil is about 5%. Once it gets in a compacted soil, you've lost a lot of that pore space. You've lost all the space for all of that soil life to be. And so that's what's happening when it's compacted. What we look at for this is, if you've got ponding happening in the soil, it means you've lost all of that, some of that pore space, and water just can't infiltrate into it. So it sits on the surface for a lot longer, or it's going to run off if you've got any kind of slope. You'll get, we measure penetration resistance, so using a penetrometer, and you might lose soil structure. You'll look at the plant roots. So this slide is showing if you have some kind of compaction down below the surface. So on the right here, it's showing what we call a plow pan. If you've plowed or managed your soil in such a way where you're maybe even rototilling soil down to about like 7 or 8 inches, right below that, often you'll get compaction. It's area that's never gets mixed up, but it's getting influence from whatever machinery are running over the surface of it. And so your roots will go down to about 7 inches and then have trouble getting any further and will go horizontally. And you're losing all of those resources below that 7-inch depth. And you'll see that if you look at your roots, they'll go down and then they'll go sideways. And so that's one of the things you can look at that might indicate that you have some compaction happening. Another concern can be just the loss of organic matter. Like I said, all of our soils really have been influenced by this. They say over half of the organic matter that's historically been stored in soils has been lost into the atmosphere. And so indicators that this might be happening is you don't have a lot of cover over your soil. You have how much the residue is breaking down. Is it incorporating back into the soil? And just kind of what the structure is, what the color is. If you have not a lot of biological diversity, those can be indicators that you're probably losing organic matter. The structure, I just want to highlight for the structure, what you're looking for in good soil structure is we call this sort of granular structure. So this is a nice close-up of it. It's like little tiny clumps, often clings onto the roots. And those are those little soil aggregates that we call them. So you can pull them off and they'll hold together. And that's really where it's creating pore space within those and between those. And it's crumbly and it's not really firm when you're trying, if you hold them in your fingers. So that's quality soil structure right there. And also what that structure can result in is having good aggregate stability. And so the alternate side of that is if you have a concern, you have aggregate instability. Aggregates, like I said, are those where the soil is holding together in those little aggregates that will hold together even under the influence of rain or under water. If you don't have good aggregate stability, you get surface crusting or erosion. So in this picture, this is really small scale, but this is erosion that's been happening in this soil. You have those little pebbles that are up on little platforms, and all the fine soil material has eroded from around those. And so that's an indication that you've lost your aggregate stability. This is an image of these next few images will show some of those aggregates. And so you look at these two soils. So this one on the left has low amount of organic matter. The one on the right has a high organic matter. They look they're dried out right here. So they look pretty similar. They both have what I would call aggregates. They all have those little clumps there. But then when you add water to them, the one on the left, those aggregates just totally dissolve. There's nothing really holding them together that will keep them beyond that. Once they were dried out that one time, they're not being held together at all. So they just totally dissolve. The one on the right, those aggregates still hold together even when water is added to them. And you can see once that dries out, the one on the left, you're not going to get the next rainfall event that happens on that one. None of the water is going to infiltrate except maybe into those cracks. It's all going to just run off. And so you've totally lost any kind of infiltration capability of that soil. And it's going to continue to go downhill. The one on the right you still have those aggregates, so you're still getting water infiltration, you could get root penetration and things like that in there. And so that's what we're looking at with aggregates and how stable they are. And so that's a nice little test you can do to see how stable your aggregates are. And then we also, this other resource concern is soil organism habitat loss. And so that's kind of similar to just the amount of organic matter, the amount of cover. We're looking at, how suitable is the soil for organic matter, and what's the evidence that you have a lot of biological diversity. We're looking at how many creatures are in the soil. Do you have fungal material? Do you have a lot of the microbes as well as macrofauna in the soil? And you have what we call biopores. So are they like pores from earthworms or pores from root channels and things like that? And so those are some of the things that we'll look at there. I'm going to try to move on here so we can make sure we have time for everybody else. So this leads us to our soil health principles to support highly functioning soils. So basically, all of this is we're making an assessment of our soils. We want to know how healthy our soils are. Do we have some kind of a concern where we need to improve the health of the soils? In most cases, we do. I think in most of our fields, we have some kind of concern. There's some improvement that can be made. And so what do we do to improve the health of the soils? Two things. Again, we're focusing on that soil biology. So on the one side of our little circle here, we've got sort of our four main principles of soil health. One side is to feed our soils, feed that soil biology with diverse crops, diverse plants, as well as improving or increasing diversity of including animals and things with it as well. So two of the things are maximize your living roots in the soil. So as often as you can have something living and growing in the soil. So that's where our cover crops and things like that come in. And then maximizing diversity. So mixing up the types of plants and then including animals as well, if that's at all possible. And then on the other side of this is protect. So we're feeding and we're protecting. Protect the soil. So minimize the amount of disturbance and maximize the amount of cover, keeping cover crops and things like that, or mulching on the surface. And so putting all of that together, we want to have try to practice all four of these soil health management items. And these things that I have on the outside here are basically our soil health practices. So practices that NRCS can help and implement on people's property that would do these different items. So things like planting cover crops, like I said, rotating, having crop rotation, adding just adding mulch or adding soil carbon amendments through compost and things like that. Like I said, mulching, reducing your tillage, so reducing the disturbance by reducing the tillage, or planting diverse covers. And one of the let's see, I just want to go back one. So, and then I have in the middle here soil testing. So testing is one of the important things that we always recommend. So there's the typical soil test of just looking at your nutrient management and what your nutrients are in the soil. But we have just recently in NRCS, we have a soil health division that has really been working on coming up with soil health testing. So it's a really difficult thing to really assess and measure. You can look at the soils and assess your soil health based on some of those visual cues that I was talking about earlier. But actually testing it and documenting any kind of change has proven to be kind of difficult. And that's, as a government agency, we always need to sort of prove that we've spent our money wisely and we have made some improvement. And that's why it's been kind of difficult for us to get soil health, to really push soil health, because it's a difficult thing to prove that we've really made improvements on it. It can be very obvious. You walk out and you say, yeah, this is really healthy soil. Look at all the organic matter, look at all the infiltration that's happening. But some of these things, we've worked with some soil testing laboratories and come up with sort of this suite of soil tests that can happen, that we can do, that'll measure more soil health rather than just the soil nutrients. And so the standard soil nutrient testing is still recommended, measuring your organic matter, your CEC, your nutrients, but we have these sort of upgraded biological and physical properties that are recommended to be measured too. And so this is something that we can help people do. We've worked with labs to kind of get these standard tests available for people. And so things like measuring that aggregate stability, how well those aggregates hold together, what the soil organic carbon is, and how well that's cycling, and what the active carbon is another test that can be done. And so this is a suite of soil tests that we can recommend, and they're sensitive to changes over time. And so we'll do some of these tests like at the beginning of somebody working on their soil health, and then maybe 5 years down the line, and see what the improvements are. And so that's one of our recommendations for soil testing. And so with that, I'm sorry I went a little bit over what I was planning to do, but hopefully we got a good overview of soil health and an intro into what we're doing with NRCS and what some of our terminology is. We're going to pass it over to Joel and Jack, who are going to talk a little bit more about actually working with NRCS and things like that. But I'm going to stop sharing my screen. And I'd welcome if there's any questions in the chat, or if people want to just unmute and ask questions. Why don't we take a few minutes for questions before we move on?
As far as the chat goes, not a whole lot of questions have been coming in there. So people, please, if you've got something specific here for Maggie, before we move on. Maggie, I thought that was great. A lot of real, relatively easy ways for people to assess soil quality, farmer friendly, a lot of good indicators to actually, assess soil quality without a lot of testing. That was a great presentation.
Yeah, so we've been working for a while. I mean, we have an older version of that sheet that I showed that was sort of developed here in Mass, that was an on-site sort of soil health assessment that people can access too. And if people are interested in doing that, definitely reach out to me, and I can help you do something like that on your property. So it's something that you can do both just on your own, or if you want to work with NRCS and have somebody else do that too, we can do that. But yeah, it's definitely a good thing to do, to document what we're starting with, and then every year go back, at the same time of year, go back and look at how many microbes am I or how many earthworms am I seeing in my soil, and what some of those different properties are, because then you can really document some of that change.
We got one question here, Maggie. How do you amend if you have large areas of soil that contain that blue New England clay that holds water?
Yeah, so you have different challenges when you have the different soil textures, and so that's where you're sort of dealing with that texture. If you're having issues with that, it's preventing infiltration because you have a lot of that clay. I don't know of any sort of physical amendments, but if you work through some of the, working with some of the soil health ideas, sometimes you can, if planting cover crops and things that, if you're having if your issue is it's very wet in the spring and you can't get out there planting in the spring, planting a cover crop that'll grow a lot in the early spring and absorb some of that water can be a helpful thing. And just improving the structure of that soil can also improve the infiltration and things like that. It's again, it's hard to. I don't know of any amendments where you can really like change the structure, the texture of your soil, because that's really what you're dealing with. So practicing, you have to be a lot more conscious in some of these areas of practicing those soil health principles very well, staying off of it when it's really wet, so that you're not losing any of the structure that you've gained over the course of the year and things like that.
All right, we got one more here from Carol. Do you work with companies diving into healthy soils like General Mills as their farmers are collecting data?
I don't know that we have here in Massachusetts. I think we do work with our larger soil health division at a national level does work with some of these organizations, and we have sort of larger agreements with some groups where they're collecting data. I don't know in particular about General Mills, but yeah, I'll definitely look into that.
Okay. With that, unless anybody's got a quick question, we can move it on to Jack and Joel.
Great. Can everybody hear me all right?
Yep.
Great.
I can at least.
Well, that's good. Hi, everyone. I'm Jack Loomis. I'm a conservation planner based out of Westford. So I serve Essex, Suffolk, and Middlesex County. And I also work with American Farmland Trust. I'm a contracting individual, so there are a few of us, one of us actually in each office in Mass. And so I do a little bit of work with farmland, but mostly I would say probably 95% of my job is working with producers and clients in the Essex, Suffolk, and Middlesex County area, some work in Worcester as well, to come out and see how we can help you. Just because we might not be able to dialogue as much as some people would have hoped for today, I just dropped my email in the chat, as well as my boss's email, who is the district conservationist for our area. If you think of anything in the future that you would like to ask, I'll be around. So with that, I just wanted to get in today to discuss technical assistance and financial assistance options that we have here in the state, and also kind of give you a general overview of how you go from this webinar, if you're a producer, to actually working with us. So I'm going to get into that a little bit as well, and then turn it over to Joel to give a more concrete kind of example of what working with us looks like. Sorry, Joel, did you say something?
I was just asking to make sure the PowerPoint was showing well for you.
Oh, yes, and that looks great. So,
right.
So yeah, I'll start. Technical assistance is one of the two kind of, buckets we put our assistance into. And this one is probably one of the more common areas where we start working with people. I think there's a sort of maybe an expectation where people think that you need to have a project or a financial need to work with us. And, that is a lot of what we do. We do help support and pay for practices, and I can get into that a bit more in a second. But also, we're happy to just work with people who want technical support. And essentially what that looks like, it really depends on what you need and what you're curious about for your land and how we can help conserve your resources. But it's free personalized advice and information. Working with a conservation planner and also with the team and support folks that we have. For example, if you're working with me and I didn't know an answer to a soil question, I'd ping Maggie and ask her to come out and help me out there, or I'd ask Joel. So we have a great group of experts at our disposal, as well as wonderful resources. And we can use those and give you deliverables, maps, guidance, really kind of anything you need. We can come out and try to help answer your questions. It is a first come, first served basis. We wish we could get it to everyone, and we usually do get there, but it sometimes takes a little while just because we do have a large volume of requests and not quite as many people as we'd love to have, but we do what we can, and we stay in touch. So it wouldn't necessarily be like the first week that you would want someone to come out, that we'd necessarily be able to come out, but we can start a process. It's got to start somewhere, and kind of give you an estimate of when we can come start working with you and supporting you and getting you to where you want to be. So essentially, the technical assistance is just going to be deliverables that you get based off of the questions you have. We'll answer them, and we'll kind of see how that looks throughout the 9-step process. So if you could go to the next slide. Thank you. Financial assistance happens sort of after the technical assistance process, but by no means do you have to embark on it. But if we have discovered that there are some practices or projects we can help with, then we can work on planning to support that financially. And I'll get into that a little later on. But that's where you would need to work with Farm Service Agency if you weren't already set up with them, just to get our eligibility good to go there. And essentially what happens is we have a couple of different funding programs, EQIP, or the Environmental Quality Incentive Program, Conservation Stewardship Program, and Agricultural Management Assistance. You don't necessarily need to know that. It's just sort of the funding pots that we have based off of what you need and what your situation looks like. We would put you in for an application should you choose to proceed with financial assistance, and we would put it in through one of those programs, just based on what it was that you were trying to do. So following that, we all submit our conservation plans to the state office for consideration. And if and when they're funded, we hear back, and then we get back in touch with you and let you know if we can go ahead with funding that project. All right, next slide. So the overview of the 9-step process is here. I'm hoping to just go through briefly each one of these and elaborate on it. And so we will dive in for determining objectives on the next slide. Oh, I jumped one, sorry. This is a visual if you wanted to look at it in a different way. Sometimes it's easier to think about things in phases. So that's just another slide if you wanted to think about the 9-step planning process in phases. Sometimes it just helps to see things that way. Perfect. So the first step is the objectives. You're going to get in touch with us, say, hey, we're looking to improve soil health, or we're looking to do something. You can peruse our website. There's a lot of opportunity to work in conservation. We offer quite a wide variety of practices. And so you would reach out to us and let us know that you were interested in getting started and working with us. Or if you have worked with us before, just same thing, reach out and we'll put you on the list and get to you as soon as we can. So that's the first step, is just getting in touch and talking to you and asking you what it is you're looking to do. Your objectives can be simple, they can be complicated. It's really up to you. You don't have to do everything all at once. It's a working process. I mean, we have files in our offices that go back 30 years for one producer, like hundreds and hundreds of pages. So by no means do you need to do it all at once or anything like that. But just getting in touch with us and kind of letting us know what you're trying to do is a great way to start. And we'll hash out, how that would look in terms of our support. And step 2, we would inventory your resources. Resources, I think, in this context, definitely one is the natural resources. For example, going out with Maggie to your land and taking a look at soil and seeing how we're doing with that. But also think of it as beyond the biological resources, the time that you have to implement things, of money that you have to implement things, you know, management practices. It doesn't have to simply be what do you physically have environmentally speaking, although that is a big part of it. But we're trying to look more holistically because we don't want people biting off more than they can chew. And we want to make sure that we set objectives and goals that are feasible. Next slide, please.
Hey,
Yeah.
Jack, some people are saying your voice is cutting in and out. Just make sure, I guess, make sure you're facing directly to the computer. I was hearing that too.
Oh, you were? Okay.
Yeah.
Sorry.
No, that's okay. Just like.
Okay, gotcha. All right. This should be better. Cool. So step 3, we're going to analyze the resources. So that's kind of in part related to the previous steps, where we're just going to look exactly at what you've got, you know, more biologically at this point, and try to identify the concerns. So maybe you've got a field with some compaction, ponding, like that. We got to get out there, take some pictures, maybe dig a couple of holes, just talk to you about whatever resource concern that you have and document it and study it a little closer. Because obviously there are so many variable ways that we can go problematically. So we like to get out and meet you and look at your land. So we at the Nrcs define concerns as degradation of natural resources to a point where it no longer functions sustainably. So if you are experiencing soil loss, you know, that's not sustainable. It's not good. And over time, it'll, you know, really become a big problem. So, you know, that is something that we want to get out and see. And then step 4, we analyze the resource data. So that often means that we're going to be doing that work as conservation planners, myself or Joel, going back and using our resources and our documents to run tests and see what kind of programmatic and financial support might improve those resources. Next slide, please.
Your voice is still cutting out a little bit, so I don't know if you can speak directly into your microphone or what, but just we're gonna.
Yeah, I'm sorry. I'm speaking directly in.
Okay.
So,
well, that's as good as we can have it. Then it's good.
Yeah, sorry guys. Well, the resource concerns listed here, an example of how we work with these things. We've got your cause and effect is a good way to think about it. So describing a situation, you know, that things are not going well, and then we come in, help you fix that. So a good example is, say you're experiencing erosion in a field, we might come in and help you plan a good cover crop, you know, when to plant it, what to plant potentially, ask you some questions, figure out what we're able to do, and then plan things that will help you improve that, as opposed to watching, you know, things just slip away. So that is sort of just the general idea of how we deal with that. Next.
All right.
Sorry, guys.
That's all right. I can fill in some of those last details, Jack, on your behalf. I'm sorry it didn't work out. We could hear you a lot of the time, but it started cutting out more towards the end. Just briefly, the last 2 steps would be, you know, implementing the plan with Nrcs, and, you know, completing different certifications. We might come out for a site visit to check to make sure that the practices that you had planned are being completed, and you know, do inspections if necessary, if you installed, you know, an irrigation system or a manure management system, for example. And then the final step would be to evaluate and repeat, and you know, continue the two-way relationship planning and working with our programs over the years. Yeah, thanks, Jack, for that review. And I wanted to follow up on that review with an example to make it a little bit, to kind of make it concrete in terms of what that could look like on an example farm. But first, to introduce myself, I'm Joel Betts. I'm a conservation planner and soil conservationist with the Worcester County Conservation District. I started back there in February. My background's in watershed science. I'm a master's in fisheries and wildlife from Michigan State. So I'm generally a conservationist, and I guess I would label myself more as an ecologist than an agricultural scientist, but I've been learning a ton more, and in this role from all the producers that we work with, and I work with producers in the NRCS office in Holden to try to implement these programs. And then I also, 30% of my job is outreach specifically for our soil health initiative, which I'll talk more about at the end. And that ranges to be with smaller landowners and larger scale farms. But a lot of work with backyard gardeners, talking about soil health and doing soil testing and helping people kind of access some of these resources that are typically made for farmers and not always for gardeners. So making that more accessible to a smaller scale. And so I wanted to go forward with our example, Fred and Fanny's Veggie Farm. So a little bit of context. They're a husband and wife vegetable farm, somewhat small scale. They've got 20 acres, some of it's in hay. They've got a mix of vegetables and rows. They've got some high tunnels, kind of a typical smaller scale veggie farm in Massachusetts. They use organic practices, but they're not yet certified. They have a CSA and a farm stand. So kind of going for a typical organic or aspiring to be organic veggie farm. And they are a little bit kind of not experienced in soil health and not innovative in that way. And so it's a good example of someone who could work with us to improve their practices and increase their soil health. So for example, they use a lot of tillage. They till, depending on the crop, but generally high intensity tillage once or twice a year, spring, fall, depending on what they're doing, especially in the spring. They've got a tractor, typical, with mobile plow, chisel plow, disc, rototill, depending on the crop. Their weed management is accomplished through black plastic, tillage, and mulch from old hay bales, since they have hay on site. And they use manure, compost, and some fertilizers incorporated into the soil through tillage. They have drip irrigation and generally don't have a set crop rotation, although things get rotated kind of in an unplanned fashion depending on the year and how things turn out. So a lot of opportunity for improvement. It's a great farm to start a conservation plan with us, which is why they reached out. So I'm going to run through that 9-step process that Jack talked about with this specific farm and how they might work with us specifically on soil health. Because when they approached us, they were interested in improving soil health. They saw that their soil was starting to become compacted. Soil aggregate stability was going down. They seemed to be losing organic matter when they did soil health tests over a couple of years. And they're also interested in expanding production and improving the long-term farm sustainability because they want to keep this thing going for a long time. And basically just need some technical assistance and hopefully financial assistance to get some of this done. So that's why they reach out to us. So someone like Jack or I could come out in step 2 to inventory the resources, do an initial site visit, walk the property, discuss farm operations, discuss farm goals, really start that conversation, maybe through a couple site visits, a couple phone calls, and get a sense of what's going on the farm. And step 3 is to identify resource concerns. In this case, we're specifically talking about soil because that was a farmer objective. And so, as part of that inventorying resources, we'll identify which resource concerns might exist. And as Maggie described, with NRCS, we have specific resource concerns that we look to identify. There's a whole list of resource concerns related to soil, air, water, social sustainability of a farm. And so in this case, I want to make the distinction between resource concerns that result from the inherent soil properties and ones that result from the dynamic soil properties. So in this case, it's a Marlowe series. It's relatively that's a soil type. It's relatively high slopes on some part of the land and not on others. So the highly erodible land it's possible that you might have sheet and rill erosion risk as a resource concern on those sloped areas. And since it's a sandy, more well-drained soil, that inherently is more prone to organic matter depletion and aggregate instability because you tend to be more prone to drought and to it's a little bit harder on a well-drained soil, depending on what it is to keep organic matter. But so those are some of the things we might consider when looking at the soil type. And then more importantly, or especially in this case, there are resource concerns for the soil that result from the current management practices. So their general heavy use of tillage definitely for them was resulting in compaction and loss of aggregate stability, so aggregate instability. Organic matter depletion, because as you till the soil, like Maggie mentioned, you expose it to oxygen, which then oxidizes the soil and creates a lot more emission of CO2, and you lose that organic matter to the atmosphere. They're prone to sheet and rill erosion, which is basically that small scale erosion that Maggie showed, and turning into larger scale erosion when you've got rills developing. And then soil, with all of that together, that results in soil organism habitat loss, which is a general decrease in soil health. So those are our specific NRCS resource concerns that we defined as resulting from heavy tillage. The use of plastic mulch, and especially the weed mat, could be resulting in compaction. We often see compaction between veggie rows, and especially if larger tractors and things like that are used. And could result in organic matter depletion and loss of soil soil organism habitat, because that black plastic, black weed mat heats up the soil a lot, and you tend to kind of solarize and kill off a lot of the soil organisms in that top bit. And the hotter the temperature, the more oxidation you're going to have, the more organic matter you'll lose as well. The lack of winter cover crops, I forgot to mention that they're not currently using cover crops. So lack of winter cover results in those three resource concerns as well. And if you have a lot of rain or snow melt, you tend to be higher erosion risk. And then the lack of crop rotation is also bad for soil organism habitat. If you remember our 4 soil health principles, one of those is maximizing biodiversity. And if you're not rotating crops over the years, you're kind of creating a monoculture of soil organisms in an area as well, which doesn't help with the resilience of that ecological community in the soil. And so our next step 4, would be to, I see a few questions there. I'll answer that quick. Solarization is really, when you're heating up the soil when you have something like when it's bare especially, or even more so if you've got black plastic, that you kind of, if you raise it to a certain soil temperature, some soil life can't survive that. So that's what I mean by solarization. We talk about solarizing to kill weeds, but if it also affects the soil life in the same way that it will kill weeds. Some certain soil organisms can't handle something getting hot, so heated up like that. So you can see that on hotter days, especially if you're getting a lot of sunlight on those black plastics. And why are they, if they're rotating but not on a set schedule, would the organism habitat be lost? So I guess what I'm trying to get at with this one is they may rotate and they may not. There's not really a plan to it. So some years they might grow the same crop on the same piece of land. Some years they might not. And it doesn't have to be a set schedule, but the idea is the more that you rotate and increase the diversity of plants on an area, the more your soil organisms will benefit from that. So the step 4, analyzing resource data, this is where we would bring in some of these, maybe a soil scientist like Maggie or an experienced planner who can do this themselves, to fill out some of these resource sheets that we have to set to document baseline conditions on the farm. And so, you might use one of these forms and do a number of different analyses to assess that. And then step 5, the conservation planner would work with the farmer to develop a crop system plan that integrates soil health practices to address these specific resource concerns that were defined. And this is where I want to give kind of an example of what this could look like. So I developed 2 alternatives. And the idea of this is to kind of assign, through developing a resource management plan, or a soil health management plan in this case, we would be prescribing different NRCS practices. And these are examples of NRCS practices that we have, as Maggie showed us earlier, that address these different soil health principles. And so, the number behind these, that's because we have a specific code attached to these. And if we prescribe these practices in a conservation plan, that's what can make them able to access cost share and funding. So these are, specific practices that have the potential to be cost shared. And these are the soil health, kind of the suite of soil health practices. We also have the ones in planning and assessment. So you can get help with a soil health test or a soil health management plan. So I'll show you how these kind of work out through two specific alternatives. The first one is less intensive and less of a change for the farmer. The second one would be a little bit more of a radical shift in the way that they're producing. So the idea is to develop a number of alternatives that the farmer can consider and weigh the pros and cons of each. So this is step 5 in the planning process. It's probably the most important step. So our first alternative, I have it on this one slide. We're talking about a 5-year period. So the first year, or right in the beginning of the process, they could hire a technical service provider like myself through the conservation district or someone else through a company that would provide the soil health management plan and take the soil health test. And so those things, as part of the plan, we would plan for the soil health management plan and the soil health test, these practices that could potentially get cost shared from NRCS. And then years 1 through 5, here's our cropping strategy for every year. As an example, in the fall, you could lightly harrow the rows and aisles and seed with rye or vetch or whatever cover crop mix is appropriate as early as possible after harvest. And so that would be these two practices: reduced tillage and cover crops. Reduced tillage, assuming they're not fully tilling, they're just lightly harrowing to the extent that they need to plant. And then in the spring every year, adding compost, which would be our soil carbon amendment practice that we can fund. Tilling in vegetable beds only, but not actually in the rows, and then using a crimper and roller, since they're going for organic practices, to roll the rye vetch cover. And then, as necessary, use weed mat or leaving mulch, or adding mulch in between the rows. And mulching is a practice that can be considered as well, and potentially cost shared as part of a conservation plan. And then, incorporating crop rotation, so avoiding repeating the crop from in each row from year to year, and then repeating this throughout the 5 years. And one idea could be alternating the location of rows and aisles every year to minimize compaction and tillage. So swapping where the row is and where the aisle is every year. Some farmers do that, some prefer to keep the aisles the same, but then you risk more compaction where you're walking every year. So that's one cropping strategy. Another alternative that we could do would be kind of a crop sequence of pumpkin or summer squash, followed by sweet corn, followed by row veggies, and repeating that. And that would allow you to actually do no-till completely. And I'll show you how that could work. So in year 1, same thing, you'd hire a service provider to make the soil health management plan and take the soil health test. And then in the next year, or in the fall, you could use a no-till drill to seed your cover crop as early as possible. And we actually have dates. If you're going to work through us, there's specific dates that you have to comply with seeding to make sure that you get your cover crop established. And it depends on the crop and the hardiness zone that you're in. And you'd likely need to harrow the rows before first seeding, so that wouldn't be no-till, but after that you would be able to do no-till. So you'd have to rent or buy a no-till drill. That's a cost. You could apply for MDAR programs for that. We don't have any through NRCS that would assist with that, or use, depending on the scale, they could transplant by hand. And they drill or plant the summer squash into the cover crop mulch in the spring after it had been terminated. And that would be qualified as a no-till practice. And as needed, they could apply compost or manure, and that could be also potentially cost shared. And I have this is a picture of rye at pollen shed. That's when you would be able to crimp and roll it and have it not be as likely to come back as a weed. We talked a lot about that in some of the no-till and talks the other day. So the next year they could do no-till sweet corn. And similar to the other years, I won't go through it. They could use cover crops. They could apply for funding for no-till practice, and potentially do soil carbon amendment by adding compost. And then the third year, rotate in veggies use a reduced till practice instead of no till after the cover crop, because they would have to till, where they did the rows, and could apply compost, manure, and then in any of these, but especially this one, they might need to consider weed suppression even more and add more mulch later in the season if necessary, or lay down a weed mat as the cover crop residue degrades. Year 4, it could repeat from year 1, summer squash or pumpkins, and year 5, repeat no-till corn, the same thing. And then year 5 or year 3, depending on how you want to do it, you could do another soil health test to see what progress is being made in terms of soil health. And I think we can cost share that through practice 216. So that's just a really brief example of some of the alternatives you could develop, through your through step 5 of the conservation planning process. And specific practices that we have that were proposed in this context were the management plan, the soil health test, residue and tillage management. This is reduced till or no till, cover crops, mulching, and soil carbon amendment. And then step 6, go through these alternatives with the farmer, have them, do pros and cons. Does it meet your objectives? Will it actually work in your environmental, social, and economic context? Are there any more concerns that are created? And after that, have the farmer make decisions. So, at that point, you decide which financial assistance programs you might want to apply for, EQIP, CSP, AMA, some of those ones that Jack mentioned, and schedule those practices. And we might fill out some paperwork at that point. And then it's time to implement the plan, whether it's a 3-year or 5-year plan. And every year, as those practices come about, we would be able to, or we would have to come out, and if you were getting funding assistance from us, we would come out and certify or inspect those practices just to make sure that the plan is being followed. If there's not financial assistance, the farmer is totally free to do whatever they would like to do in terms of following that conservation plan. It's more just a guideline. If there is cost share happening, we'll come out, at certain times of year and certify the cover crops, for example, to make sure they were planted on time, or come out in the summer and make sure that crops are being rotated from year to year, things like that. So general notes about conservation planning. The plan is flexible and adaptable to consider farmer needs. It's a living, breathing document. It's a conversation. It creates a framework for funding if the farmer decides to apply for programs and is selected for funding. And then if they're selected for funding, then, like I said, those practices will have to be followed and certified by an NRCS planner for the funding to be able to be received. That doesn't mean that you can't change it partway through if something's not working. Obviously, it's a conversation, but then you might shift things a little bit in terms of the cost share that's going on if you're not able to comply with the practice. And the last step is to repeat the process. At the end of that plan, you could figure out how things went, reevaluate, reapply for programs, and continue from there. And so that's kind of the 9-step process in an example farm, for example. And Jack already went through some of these, but just to review, these are some of the different financial assistance programs available through NRCS. And then we also have general conservation technical assistance, which doesn't have a financial component. We can do that whole 9-step process, and there's no obligation financially within that, or no cost share that we would provide. And we're able to do site visits as well. And then one other mechanism is if you're an organization, a nonprofit, especially, or a farm that wants to do an innovative trial or a project, there's specific funding available for that. And for example, Davidian Farm Market this year got funding they worked with us in the Conservation District to make an application to do a project that's integrating cover crops and reduced tillage using a new plastic mulching technology and shaped bed vegetable production. I'd be glad to talk with anyone about that project that I worked with with Mike Davidian to kind of do on their farm. But that's more for trials that are available to people.
I work for Farmlands, American Farmland Trust as well, and they have some really incredible resources to keep your eyes peeled in the coming year.
And I'm not going to run through, we're out of time. So just to briefly mention, our conservation district also works with any scale of landowner. So definitely reach out to us through our website or through chat here I'll put my email. We do soil testing through the UMass UMaine labs and can come out and do that for you and assess your soil. And I'll also walk your property, and I can provide assistance on composting, pasture health, creation of pollinator wildlife habitat, invasive species control, garden creation, cover crops, any of that stuff. And then we also do workshops and webinars. And that's, me and some of my colleagues here at the district, that's available for smaller landowners, non-farmers, and farmers if you want, but typically people have their sources for that figured out already if they're a farmer. We did a lot of that this year, and I'll, I guess, leave that for a second, but skip through it. And we have our own funding sources through the state and some national programs as well that allow us to do that. But I know we're out of time, so I don't know if we have time for questions, if there's a break between these two periods, but I'll turn it over to John to wrap that up for us. I appreciate everyone's attention.
Joel, thank you guys. It's a lot of information. Definitely, most everybody has posted their email in the chat. One thing I do want to remind y'all is to save that chat with all these links. If you hit the three little dots down where you type in, you can save everything that's been in the chat so that you've got their emails and whatever related links got posted in there along the way. These guys' emails are all pretty easy. It's their name at USDA, so and they're pretty easy to track down. There is one question, Joel, in the chat about Jessica's asking about cover cropping, and I know we're getting close to running out of time, but I'm going to throw it out there. Maybe you can get at it. Cover cropping on a small, she's working on a 10,000 square foot piece of land, and harvesting ends in November. Any suggestions for what mix to plant and how to cover crop through the winter? She's reluctant for timing's sake, typically planting in late March and April, cold hardy flower crops. Any suggestions?
Well, I think if you've got a crop on the land until November, and then you're planting another crop already in March or April, I don't think that you necessarily need to have a cover crop in that system, or there's not really anything that's going to grow more than those things. But I think most farmers are going to have, and maybe Maggie can provide other thoughts on that, but I think most farmers, like if you've, for example, some crops are more are easier to cover crop and others aren't. For corn, for example, you can pull it off by mid-September and you're planting it on Memorial Day, for example. Well, that's a long period where rye could grow, rye and vetch could grow. If you've got peppers or tomatoes that come off too late for cover crop to get in, if you're taking some of those plants off in mid-October or whatever, maybe it would make sense to plant a spring cover like oats or peas if you have a later spring planting date. But if you've got a late harvest date and an early spring date, depending on your crop, yeah, it doesn't always work. And I don't know if maybe Maggie's got other thoughts on that.
Yeah, no, I think you covered it. On a small scale, I mean, you can go bed by bed too. Like if you have some beds that you're out early, just try to throw some seed on those. And so do the best you can. It's not always going to work, but there's definitely ways around it, or even interseeding if you're able to, plant it while things are still growing, and then and then let it just continue on through the winter. The other thing is, if you can't get a growing crop, the next best thing is just having good mulch. So keeping it, keep the soil covered through the winter in some way or another is the next best alternative.
Yeah, I know. I see Pat Barnowski's on the call here. I saw that we worked with some cover crop workshops with them at their urban farm with the Regional Environmental Council, and they the way they did it was, later in the season, throw down cover crop seed in between their vegetables, and as the time of the vegetables are wrapping up, you've got those small cover crop seeds starting to germinate, things coming up. They're not competing that much in those 2 weeks that they're starting to germinate, and by the time they're starting to grow up, your vegetables are senescing, and you've got them in on time before things freeze. So that's a strategy that can work on a small scale. At least I've seen. I know that they've got great cover crop coverage now on that farm. So that's, I think, an innovative way to do it on a small scale.
No, that's great. I did post a link to our survey in there. Anybody, if you could take the time to check out the survey on the conference, that would be great. We really appreciate your feedback. And again, check out the auction. And thank you guys for presenting. Jack, Joel, and Maggie, that was great. Some really good, useful information, and it's pretty apparent that y'all are out there to help, and that's nice to know, because gosh, no, it's complicated, and we need all the help we can get. So thank you for your time. Thank you for being here. Thank you guys for attending. We all appreciate it. I'll leave this open for a little bit longer. If you do want to copy the chat, please do so. And thank you, and have a great day.
Great, thanks everybody. I'm willing, if there are other questions, I'm able to stay on for a few minutes. I see a couple, like Maureen is just asking about what good mulch there is. Are we able to stay on and have a discussion if people want to?
I think we can keep it open certainly for the next 3 minutes.
Okay.
So so yeah, go ahead until we get kicked out. What the heck?
Yeah, just covering what kinds of mulch there are. I mean, really it's what you have available, but you can use like leaf mulch, ground up leaf is good, straw or hay mulch, or if you're able to, the best alternative is if you're growing something that is like a cover crop, and then you can lay that down and use that as mulch too. Those are all good things to use as mulch. Mainly it's just, if you aren't able to have a growing crop, have something that's physically protecting the soil surface through the winter. And then there's a question also on the conservation district. So Joel, you're with the Worcester Conservation District. What's the status of the other counties? Are you aware of that? I know each county has the potential to have a district. It depends on how active they are.
Yeah, Middlesex County has a pretty active district. They don't have a conservation planner like me, though. They don't have someone who can come out and do site visits in the same way. And I know that the districts are trying to get more active, and their district is, they have a seedling sale. They have a few resources they can provide, but it really depends. I know Hampshire does have a conservation planner. I think that there's a few others that may as well. I've only, because of COVID, I haven't had as many chances to meet people since I started in February. But I do know that exists, and our district is one of the most active in the state, definitely, and has the to have a full-time staff who can come out and assist. So we're trying to help other districts get to that too. But the state has some funding sources that make that possible, and districts can apply for those, and you can get active in your local district and get on their board of supervisors and help make that possible for a district by helping them write grant applications and finding staff, if that's something you're passionate about.
There's the Cape Cod Conservation District as well, as for Barnstable.
Right, they have staff, right, Maggie?
They do, yeah.
Joel's 100% right, though. Actually, I haven't been an ex-conservation district guy. If you've got an active board, which is the people in your community that are involved in that district, that's the best way for your conservation district to get support and be able to employ somebody like Joel and have staff. So get involved.
Yeah, it's under tapped resource, and there are specific grants for conservation districts. So it's just a matter of the community organizing to help get them to be active.
Very much. Yeah. All right, guys. This has been great. Thank you.